Hi everybody, so we have a square here, and in this square from the vertices we draw some lines that are perpendicular to each other, and in the remaining areas we inscribe circle such that all the circles are equal. So in this beautiful figure, if the length of the square is 1, then we need to find the radius of the circle. So first you please give your trial to this question and keep watching for the solution. Now we need to learn a theorem which I almost use in my every video if we have a circle. So there is a circle and the center of the circle is O, and we choose a point A in the exterior of the circle and we draw two tangents from this point A to the circle. Now we draw radius to the tangential points, so we know that they are perpendicular. Now let's call them B and C. Now join the points A and O. So in triangle AOB and triangle AOC, angle ABO is equals to angle ACO is equals to 90 degrees by tangent theorem, and side BO is equals to side OC, radius of the circle, and AO is a common line. Therefore, triangle AOB is congruent to triangle AOC by right angle hypotenuse side rule. Now, after this congruency, we can say side AB is equals to side AC due to the corresponding parts of congruent triangles. It means these two lines are equal. Now, we need to learn one more thing that is not much important, but I will tell you this only for the information. So, if we have a line and on this line we have two circles that are tangent to a line that is perpendicular to our first line. Now these are the centers of the circle. First we draw the tangential lines, and similarly like this. Now we have this line, so this figure is a square, so this line is also equals to this. So similarly on the right side we have this thing is equals to this. So this complete line is a straight line which is equals to the 2 times of the radius of the circle. So this is a straight line. So now here is our figure and we need to focus on this rectangle. So here is our figure. Let's call this with the center of the circle. First draw the lines to the tangential points. We know that this figure is a rectangle, so all the angles are of 90 degrees. So these all angles are also of 90 degrees. So this is a radius of the circle. So due to this right angle thing, we can say this line is also equal to the radius of the circle, which is r. So similarly this is equals to also r, and similarly these lines are also equals to r. So it means this figure is a square having the length of 2r. So here is our figure. Now using this thing we can say these all circles are tangent to a particular point. Now this line is equal to this line by our this theorem, and we know that this blue line is equals to r, which we prove further. And so similarly this thing is equals to this line, and this line is also equals to this line, and this line is also equals to this line, and similarly this line is equals to our blue line, similarly this and this. Now extend the sides, diagonal sides of our figure. So we have this figure which is working as a parallelogram. So we have these opposite angles are equal. So if this line, let's say this red line, so this red line is equals to this, and similarly these lines are also red lines because we have these angles are equal and these circles have also equal radius. So these lines are also red lines. Now looking in our this complete line, so this is equals to this line which is a plus 2r. Now looking in our this figure, in this right angle triangle we use Pythagoras theorem. So we have 2a plus 2r whole square is equals to r plus a whole square plus a plus 3r whole square. So now expanding this more, so finally we have 2a square is equals to 6r square. So we have a is equals to r under root 3. Now using this relation, we have given the side of the square is 1. So we have 1 is equals to 2a plus 2r, and putting a is equals to r under root 3. We have this, so we have r is equals to 1 by 2 under root 3 plus 2, and that is our correct answer. And don't move further, I have something to inform. So I have uploaded this video 11 days after the recent video, almost 4 days later than the schedule. And this is due to the shortage of good problems. Therefore, I need your support. Please send your valuable and nice problem on my emails. So here is my email, which is yourmathsguy1910@gmail.com. So everyone will able to access the problem over worldwide, and I hope you will send your valuable problems on my email. So it's time for the rating of the problem. So for this problem, for creativity, I want to give this problem 3 points out of 10, and for mathematical thinking 2 points out of 10, and for focus needed 3 points out of 10. So the average hardness of this problem is 2.6 bar.